Hi everyone. Welcome back to class after the break. During the break, we ended up talking a lot about quiz logistics and realized that there was a lot of questions about the first quiz, which will be next week and is online. And so we're going to take some time and go through some of the questions on quiz 1 as well as the logistics. So if you're watching this on the YouTube later, you missed some of the general questions. Hopefully they're all questions that were in the emails that you received, but if not, please ask on Piazza. And as for the quiz itself, that should be on CrowdMark. So if you sign into CrowdMark, you should be able to sign in on Quercus. And then there should be a class that is the magic of numbers. So this is, I distributed an ungraded practice quiz 1. And I don't know exactly what you see because that's not what I see. But on the questions, I can preview the assessment. Except my previewed assessment is not the one that you see. So let me try to get the previewed assessment. Oh, where is that one? Chrome. Wait, why is that not showing up? Ah, there it is. Okay, so you should see a CrowdMark assignment of this kind. Oh, is my green screen is leaking. Okay, so you should have received this email. On the email, you have this ungraded practice quiz, and this PDF here, link here, will be the PDF that will be officially given to you. Okay, so this is the PDF that will be officially given to you. At the same time, on the Zoom, since the first quiz will be over Zoom, your TAs will also put this PDF into the Zoom. And so you should get access to it at 3:20, or sorry, not at 3:20, at 9:20 or at 3:20 or 20 minutes after. So like 10 minutes after your tutorial starts, you will get access to this PDF. You'll notice that there are 3 different slots. For your answers, you will drag and drop whatever answer PDF that you scanned into here, etc. Can we use an iPad as a writing tool? Yes, you may use an iPad as a writing tool. You just then export to PDF, and then you can drag and drop it in. Okay, so what are the questions on there? The questions on there are going to be... let's see. Oh, not Zoom chat. No. Wait, where are the questions? Sorry, I am doing things that I wasn't expecting to do with my setup, and I am confusing myself considerably. Where is it? Chrome window capture. Ah, there it is. Okay, so now I'm back. Okay, so are we still using Elder chat? I am still reading both chats. So for this class does not count. This lecture portion doesn't count towards your tutorial. To your participation score. I'm just using both chats and to reply to questions. And what we're doing right now is basically just discussing the quiz. Since I know we have a lot of questions about the quiz, you should also ask your TA in tutorial, since they'll be the ones actually proctoring your quizzes. Do we need to write out the complete arithmetic procedure, or do we just need to write out the answer? You need to write out enough of the arithmetic procedure to let us know as graders that you actually know how to solve it. So, for example, let's give, let's see, one note. Let's see, I probably need to make this smaller. iPad G. Sorry, this is not what I was planning on doing, and so I don't have everything set up properly. Okay, let's make that bigger again. Okay, so for example, on problem 1 on the quiz, that was just solving, on the practice quiz, I was solving a linear equation. So 2/3 x plus 8 over 5 is equal to 3 over 2x plus 7 over 20. So you could, if you knew the answer offhand, you could just write down the answer. But that is not sufficient. So you can't just write down x is equal to whatever and write that down. You will not get credit if you do that. But you don't need to show out all the steps either. You just need to show out enough of the steps that I know that you know what you're doing. So maybe you might say something like multiply by 20, and then when you do that, you end up with 40 over 3x plus 32 is equal to 30x plus 7, right? So we just multiply by 20, and then maybe we multiply by 3, and then that gets you 40x plus 96 is equal to 90x plus 21. Move stuff around, so then that gives you 50x is equal to 75. So x is equal to 75 over 50. You need to simplify, because I did say that you need to put it in the simplest form possible. So that's 3 halves. Okay? So you don't need to write out all the entire step-by-step, but then write out enough of the arithmetic that I know that you're actually solving it, and not just plugging it into your calculator. Because some of your calculators will be able to just solve this problem. I want to know that you know how to solve the problem. Oh yeah, so like some people just multiply by 60, and that also works. Would a mixed number also be simplified, simplest form? If you put in a mixed, yes. So there are many different ways of doing this. So for example, if you multiply by 60, that would also immediately get you to the answer. So that would immediately give you 40x plus 96 is equal to 90x plus 21. And then you do the same thing, 50x is equal to 75, x is equal to 3 halves. If you run it as 1 and 1/2, you will also be getting credit. If we have our own methods for solving these kinds of problems, would that be okay so long as we show our work and get the same answer? Yes. So you are allowed to, there are many different ways of solving these. And I am, unless I tell you, so sometimes I will tell you use a particular method. So for example, on the practice quiz, I said something like, use the Euclidean algorithm. If I tell you to use the Euclidean algorithm, then you must use the Euclidean algorithm, even if you know some other way of doing it. But if I don't tell you to use the Euclidean algorithm, if I just tell you to solve, well, you can do this in a different way. So there are a number of other ways you could solve this problem, so long as you get the right answer and you show your work. Okay? Let's see. So we had a question about the last one. So I am going to, about the greatest common, Euclidean algorithm, greatest common divisor thing. So I'm actually going to show you this via the ungraded problem. So I'm going to walk you through this step because I have this all written out nicely. So let me show you a couple different ways of doing it. So this is from your ungraded problems. So some of your TAs may also go through this in your tutorial. Yeah, so some of your TAs will be going through this again, but this is important. So actually, let me just make up another number. So let's make up another number. Give me 2 numbers, any 2 numbers in chat, and we'll see if I can do this on the fly. Okay, 75 and 1,938. So let's see, Maria gave 75 and 1,938. Okay, well this will be fun. So we want to find the greatest common divisor of 75 and 1,938 using the Euclidean algorithm. And I apologize. There appears to be a little bit of lag right now in my in my computer. So if I'm speaking, there might be a little bit of lag before it shows up on the screen. Okay, so how do we do this? So what we want to do is we want to find 1,938, and we want to figure out when you divide this by 75, what's the remainder? So let's do this over to the side. Divided by 75. And we want to know what the remainder is. Oh, let me turn off my poll, just because we don't need that right now. Okay. So divide by 75. Well, how do we do that? Well, we do long division. So that's 2. That's 150. So 238. So that is 3 times 75, which is 225. So the remainder here is 16. So hopefully you guys are checking your work, checking my work right now. In the quiz, can we use the calculator to do divisions like this? Oh, yes. So you can do divisions on the calculator. I'm doing it by hand because I want to show you that you really can do any of these by hand. Oh, I did that wrong. Did I? I did that wrong because that's 225, and that is a 3, so it's 13. Yes, so you can do you don't need to do long division. Oh wait, did I do that? I did that. I must have done that super wrong. What happened? Why is it 238? Oh, because I can't do math. So, this is why it's useful to check your work, because sometimes you make mistakes, or sometimes I make mistakes. So let's see, that was 2, right? So that's 438, and so then that's going to end up being, let's see, so that is going to be 5, right? So that's going to be 5 times 75 is 375. 3 is 13 minus 7 is 6. Remainder 63. Yes. So thank you for checking my work. So it is helpful if you have a calculator for this. You can do it by hand and you can check. And it is useful to check. So 1,638 is going to be then equal to, let's see, so what is this? This is going to be 75 times, let me put this in a different color, 75 times 25, and the remainder is 63. So plus 63, right? Okay, so you can do, so that is the first step. And so this implies that the greatest common divisor, let's call this D. So then that implies that D is equal to the greatest common divisor of these two smaller numbers, 75 and 63. Okay? And then we repeat the process. So now we move the bigger of the numbers, whichever one that is. So that 75 is equal to 63 times something. Well, this one's easy. So this is 63 times 1 plus, and what are we left with? Let's see. What are we left with when we do this? Well, we're left with 12, it looks like. Right? So 63 plus 12 is 75. So this implies that D is now the greatest common divisor of 63 and 12. So if we keep on going, so we have 63 is equal to 12 times 5 plus 3. Where did the 1 come from? Oh, the 1 because if we have 75 and divided by 63, that's 1, remainder 12. Yeah, so I just didn't write out the long division there. And yeah, what's up? Divisor. Yes. Yes. So one of the things you should notice is that the greatest common divisor of 12 and 63 is the same as the greatest common divisor of 63 and 12. Yes, you'll get, well, you always have to divide the bigger number into the, divide the bigger number by the smaller number, right? Because the other way, like, you don't get anything. Yeah, so you're trying to get smaller numbers, and so that's why we're doing this process. Remember, the reason we're doing this is because when you take the greatest common divisor, it turns out that the greatest common divisor of 63 and 12 is also equal to the greatest common divisor of 51 and 12, if you subtract 12 from the bigger number. And so you just repeat this, greatest common divisor of 39 and 12, which is equal to the greatest common divisor of 27 and 12, equal to the greatest common divisor of 15 and 12, which is equal to the greatest common divisor of 3 and 12. So that's what we're actually doing when we're doing division. You can also just take subtractions over and over again, but that's obviously slower. So this is... Ah, okay, yes. Let's go through that a little bit. Actually, we're almost finished here, so let me finish this up, and then I'll go back to that, okay? So, let me finish this up first, because we're almost there. So, then 12 is equal to 4 times 3. 3 times 4. So there's no remainder, which implies that the d is equal to 3. Okay, now let's take another step back. So I wrote this big long one here, right? 1938 is equal to 75 times 25 plus 63, right? Where did that come from? So 1938 is, well, what we're doing is we're dividing by 75. So when we divide by 75, what do we get? Well, that's what we did the longer division for. What you end up getting is 25 remainder 63. Okay? Another way of thinking about this is means that 1938, I keep on writing 83, because that's a number that's fixed in my head, unlike 38. But anyway, so 1938 divided by 75, that's equal to 25 and 63 over 75, right? So that's another way of writing out their division. So it's 25 remainder 63. And so when you subtract out 25 on both sides, or sorry, when you separate this is equal to 25 plus 63 over 75, and you can multiply both sides by 75. So 1938 is equal to 25 times 75, or I guess in this case, 75 times 25, plus 63, which is where we got that line from. So basically what you're doing is you're dividing and then you're getting some smaller number and the remainder. So each time you get the remainder, the remainder is obviously smaller than both of your numbers. And you keep on going until the remainder is equal to 0. And so when the remainder is equal to 0, then that's when you know you found your greatest common divisor. So the greatest common divisor of 12 and 3 is then going to be equal to 3. Actually, let me just move this up slightly, since there's no need for you to see my tools. Okay, so hopefully that explains a little bit more of the Euclidean algorithm. And then you also have to go backwards in order to figure out what the greatest common divisor is equal to. So that's going to be a little bit trickier as well. So that is also, I also have an example of that in the ungraded problems. So you should definitely ask your TA to go over that, or I'm also happy to go over that because I will be starting office hours soon anyway. So yeah, but we had another question about problem 2 from the practice quiz. So let's look at problem 2 from the practice quiz, and then I will stay around and answer questions until basically people stop asking me questions. So let's go over to the practice quiz, and let's go over to problem 2. And so that was a rewriting exponents. So I'm not going to do this one because I want you to have practice. And so I'm just going to make one up, and then we're going to do that one, okay? So let's make one up. That's rewriting exponents. Okay, so let's see. Let's say problem 2, rewrite exponents. Okay, so I give you something complicated. So maybe let's say this is x squared. Let's say y to the fourth, y to the minus 8, z to the 0, z squared divided by, let's say, 16, x to the minus 4, y to the 0, and z to the, and just z. Okay? And let's say that entire thing is to the negative 1/2 power. Okay? So I've just made a, oh, we also have a question about part B of the Euclidean algorithm. We'll go back to that after we do this part 2. Okay? So we need to rewrite exponents, right? So what are we doing? Well, there are a couple different things you'll need to notice. One is that you'll need to convert this. So how many copies? So let's just start by looking at the x's inside the parentheses. So you have a 2 on top and a minus 4 on bottom. But if you have a minus 4 on bottom, that's the same as a 4 on top, right? And so if you take this and multiply together with that, what you're left with is x to the 6 on top. Because that's 2 minus minus 4. And for y's, you have 4 minus 8. So that's minus 4. And for the z's, you have a z on top divided by 16, right? And this is all to the minus 1/2 power. So if we were to rewrite the wrong number on the quiz, not catch it, and have the wrong answer, would you not get any marks? You would get partial credit, but you would get marks taken off. So we will be giving partial credit on the quiz for showing work. So for example, if you were to just write down something wrong, you would get some amount of credit. But if you're not entirely sure, then one thing you can do is you can rewrite this as, if you did the x2 minus minus 4, y 4 minus 8 plus 0, z2 minus 1. If you wrote that out and then somehow did the wrong thing going from this step to that step, you would get almost all of the credits. You get the majority of the marks because you clearly knew what you were doing, you just made a mistake. But if you just wrote this immediately, you might get fewer marks because I wouldn't be able to see the process. If it's just y, would that be equal? Yes, that's important. Yes. So this here, if it's just a y, it's if I don't have anything there, then it's to the 1. So the z is to the 1, which is why we could do the z2 minus 1 over here. Okay, so now that we've done this, well, we also have a negative sign in the exponent there, so that just means we flip things, right? So this is now 16 x to the 6, y to the minus 4, z to the 1/2, right? But with minus signs, you might want to flip them, so that's equal to 16y to the 4th over x to the 6, z to the 1/2. And when you have when you take the entire thing to the 1/2 power, what you do is you just multiply it through the exponents. So that's now 16 y to the 4 times 1/2, x to the 6 times 1/2, and z to the 1 times 1/2. So then that's equal to, oh, but don't forget the 16 is also to the 1/2. Well, what is 16 to the 1/2 power? 16 to the 1/2 power is just 4. So that's equal to 4y squared x cubed z to the 1/2. So if you wrote that, I would give you full credit, or if you wrote 4y squared x, yeah, so that's probably the easiest way to get full credit is to write that. Because the question said I want everything to be a positive exponent. And for x, y, and z to only appear once. Any other questions for this part? Did I do that wrong? Yes, so you have to be a little bit careful. So I assume you're talking about this step here. So There are several things you can do. What I'm doing is I'm making use of this negative sign right there. So another way of thinking about this is I'm multiplying everything by -1. So that another way of writing that, let me do this in a different color just so that it's clear. Another way of doing that would be to, let's say that's x to the -6, y to the 4, z to the... Oh, wait, did I mess that up? No, well, that's right. Okay. Z to the -1 over 16 to the -1 to the 1/2, right? So then now when I do that, that's equal to, well then I can flip everything around. And so the negatives go to the bottom and the positives stay on top. So that's y to the 4th, 16y to the 4th, x to the 6th, z to the 1/2. So you get the same answer if you do it in a different order. We have another question in chat. Do we have to work out the ones in the bracket first? No, you don't have to. You can multiply it through first. So like you can do things in different orders so long as you remember all of the rules. So we had a bunch of like 5 or 6 rules of powers. If you remember all those rules, you can apply them in whatever order you want. Though you have to be a little bit careful about like how you apply them. I personally recommend that you do the stuff in brackets first, because when you do the stuff, when you don't do that, sometimes it's easier to make mistakes, but you're absolutely free to. So, for example, if we want to do this entire thing a different way, so let me put in yet another color. So if we want to do this entire thing a different way, let me rewrite that actually. So we have all this. So x squared, y to the 4th, y to the -8, z to the 0, z squared, 16, y to the -4, y to the 0, z to the -1/2. So we can also write this a completely different way and just like multiply through first. So this is also equal to x to the -1, y to the -2, y to the 4, z to the 0, z to the -1, 16 to the -1/2, y to the 2, y to the... Oh, was that a 0? That was a 0, wasn't it? Oh, sorry, that's an x. That's what I messed up. So there is an x to the -4. That's x squared. Y to the 0. Z to the -1/2. So you could start by multiplying it out, and then what happens is as you keep on going, well, then what you're left with is you're left with wait, I think I did something wrong. Oh, no, I did it right. Okay, good. So the x to the -1 on top goes to the bottom. So the 16, so let's see. So let's just move everything to be positive. So you have 16 to the 1/2 up here. You have x cubed down here. You have y squared up here. The z to the -1 and -1/2. So you have z to the 1/2 here. And so that's also equal to 4y squared x cubed z to the 1/2. So you can do it in a different order so long as you're careful about what you do. Okay. Let's see. We had another question, right? How do we do part B of the question? So I think that's going back up to this question. How do we do the other half of this, right? Yeah. Oh, for the record, class is dismissed, so you don't have to stick around. I'm just going through quiz review, which your TAs will also be doing. And so some of your TAs are really good at explaining stuff, and so if they're better than I am at explaining stuff, you should feel free to go to them instead. Okay, so let's give ourselves a bit more space. So, and actually I'm going to give myself more space here. So we now know that the greatest common divisor is 3, right? And we want to rewrite 3 as a combination of our first two numbers. So we want to find 3 is equal to 75 times something plus 1938 times something else, where x and y are integers. Okay, so that's what we want. How do we get there? What if the remainder is not 0? The remainder will always be 0 eventually, Because if the remainder is not 0, eventually it will get down to 1. And anything divided by 1 has a remainder of 0. And in that case, the greatest common divisor will be 1. So the greatest common divisor will always be some number greater than 0, because the remainder will eventually be 0 when you do this over and over again. So what do? We want to find that, but what do we have? So we have, let's say, this statement here, and we can rewrite that, right? So we know that 3 is equal to 63 minus 12 times 5. Right? What does it mean to be for the greatest common divisor to be 1? If the greatest common divisor is 1, that means that there are, basically that the two numbers don't have any divisors in common, because every number is divisible by 1. This is actually a very special condition that we'll give a special name to. So it means that the two numbers are co-prime, but we haven't introduced that terminology yet. Are these going to be posted? Yes, I will post these. So I will post these, and I'm also recording right now. So this isn't really a lecture, so to speak, but this is something like a course review. Yeah. Okay. So so if you have to leave, these will be on YouTube later. Like I said, this isn't part of the class proper. This is just me reviewing stuff for y'all. Okay, so we have 3 is equal to 63 minus 12 times 5, right? So that's from that red line there. But if you look at this, let's call this the green line, we also have that 75 is equal to 63 plus 12, right? So that means that 12 is equal to 75 minus 63. So we can substitute that in. So from the green line, we now know that 3 is equal to 63 minus 75 minus 63 times 5. Okay? And so now we collect together the terms. So 3 is equal to, well, how many copies of 63 do we have? Well, we have 1 copy from the 63, and we have another 5 copies from the right term. So now it's 63 times 5, right? So 63 times 5 minus, times 6. There are 6 copies now. 6 copies minus 75 times 5. And if you have a calculator, you can check to make sure that you're still doing the right work by just checking to make sure that this is still true. So what is 63 times 3 times 6 minus 75 times 5? Can I go a bit slower? Yes, absolutely. So what we did here is we took this 12 is equal to 75 minus 63, right? Which we got from this line here. And then we substituted in this part in for 12. So we just replaced it. Okay? So we replaced it, and then what we did is we expanded. So let me actually expand this out slowly, just to make sure that we don't get confused. So if you expand it out slowly, that'd be 3 times is equal to 63 minus, we will just use the distributive property, 75 times 5 plus 63 times 5, right? And so then 3 is equal to 63 times 6 minus 75 times 5. And just a moment, the sun is in my eyes. Okay? So now what we have is now we take a look at the next line. So we also have, let's put this in orange, we also have this line here, right? Up here. So 1,938 is equal to something. So that means we have 1,938 is equal to 75 times 25 plus 63. Well, we can rewrite this as 63 is equal to 1,938 minus 75 times 25. Right? But now we know this. And so we can replace 63 with this other equation. So you're going backwards. So you're doing the opposite of simplification. Oh. Am I frozen? So now we replace that in, so that gives us 3 is equal to 1,938 minus 75 times 25 times 6 minus 75 times 5. Okay? We expand that out again, so 3 is equal to 1,938 times 6 minus 75 times 25 times 6 minus 75 times 5. You're a bit confused. How did the second line become the third line? Okay, so you're confused about this step, right? How did the second line become the third line? Is that the only question you have, Aaron? Okay, so let's walk through that line a little bit more slowly. So let's expand that out. So we have 3 is equal to 63 minus 75 minus 63 times 5, right? So now we're going to use the distributive property. So 3 is equal to 63 minus, if the distributive property is 75 times 5 minus 63 times 5, right? And then we distribute out the minus sign, so then 3 is equal to 63 minus 75 times 5 plus 63 times 5, right? And then what we can do is you can rearrange. This is 63 plus 63 times 5 minus 75 times 5. And then you can use the distributive property again and then factor out. So yes, so I'm going to get to that now, Jocelyn. So then 3 is equal to 63 times 1 plus 5 minus 75 times 5. Okay? So that's how we get the next line. So then 3 is equal to 63 times 6 minus 75 times 5. So you're basically doing you're factoring out. You're doing a reverse distributive property. Does that answer your question, Jocelyn? So I think this is the line that was confusing to you. Okay, so now sorry, I was skipping some steps, and so I'm trying to be really careful about doing the step by step here. Okay, so now we keep on going on the left-hand side. So what we've done is we've multiplied this out, and then we have 3 is equal to, well, let's collect together the terms. So 1,938 times 6 minus, well, this is 75 times 25 times 3 plus 5, right? So again, we're using the same property. We're factoring back out to get something times 75. So then 3 is equal to 1,938 times 6 minus 75 times, well, what's 6 times 25? That's 150 plus 5. And so then 3 is equal to 1,938 times 6 minus 75 times 155. And once you have this, you also need to double check your work. So this is where a calculator comes in handy. So if we go over to a calculator, we can type in 1,938 times 6 minus 75 times 155, and hopefully that is equal to 3 if we did everything right. Yes, so we did everything right, which then leaves us with a way of writing number 3 as a combination of our two numbers, 1,938 and 75. Okay, yep. Have a good night, everyone. Have a good morning. Okay, any other questions about all this? Oh, no. Let's go through it slowly. Let's see. So let's go back over to what we're doing there. So let me give myself some space. So I apologize, I have... Okay, so the question is, we have 3 is equal to 63 minus 12 times 5, right? That's our starting point, and hopefully that makes sense. And we also know that 75 is equal to 63 plus 12, right? And that came from one of our equations up here, right? So what we want to do now is we want to say, well, then 12 is equal to 75 minus 63, right? So now let's introduce a new variable. Let's say that x is equal to 12. Maybe not x. Yeah, sure. Let's say, no, we already used x. Let's say a is equal to 12. So let's call a is equal to 12. Okay? So then you can rewrite this as 3 is equal to 63 minus a times 5, right? But if a is equal to 12, a is also equal to 75 minus 63. And so we can plug that in instead. And so 3 is equal to 63 minus 75 minus 63 times 5. Okay, did that answer your question? Yeah. Okay, Lewis, these common multiple questions again. So that is a fact that we showed in class. So the greatest common divisor, so if we have two numbers a and b, then we want a useful fact is that a times b is equal to the greatest common divisor of a and b times the least common multiple of a and b. So if you wanted to get the least common multiple of, so then another way of rewriting that is least common multiple of a and b is equal to a times b divided by the greatest common divisor of a and b. So for example, in this case, we have 1,938 and 75, right? So the least common multiple of 1,938 and 75 is equal to 1,938 times 75 divided by the greatest common divisor, which is 3. So that's going to be equal to 1,938 times 25, which is a little bit painful, but let's do it. So 1,000, what is that equal to? So I'm going to do this a quick way because so 1,938 is equal to 2 times, let's see, what is that? Is equal to 2 times 969, is that right? 1,018, 12, okay. So then this thing is equal to 2 times 969 times 50, which is equal to, times 25, which is equal to 969 times 50. And multiplying by 50 is easy because then you just divide by 2, so 969 divided by 2. So this is equal to 969 divided by 2 times 100. So that's 4, 8, 4, remainder 1. So this is equal to 484.5 times 100, which is equal to 40.450. Yeah. Would you recommend finding the greatest common divisor of a and b first before finding the least common multiple? Yes, because we have not, the only way I taught you 2 ways of finding the least common multiple. One way is to list them out, but that can be really fairly slow. The other way is to find the greatest common divisor first. And yes, so if I ask you to find the least common multiple, I do recommend finding the greatest common divisor first. And yes, you can use a calculator to do all this. I don't actually know if I did this right. Let me double check to see if I did this right. Times. Okay, great, I did it right. Like everything we do can be done by hand, but sometimes it is easier to do it with a calculator. Okay, is this all the questions? so with that, I will end I guess, the sort of early office hours. I'm not actually sure, and I will stop recording. So, oh, what's up? Oh yeah, what's up? Occurs only once. So yeah. Oh yeah, sorry. So this question is exactly the same as problem two on the quiz. So you'll notice that many of the questions on the quiz are very similar to this. So each of these questions is basically a practice for the quiz problem number two. Oh, sorry. They mean the same thing. Yes. 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 Only once. Yeah. Let me edit that just so that no one else gets confused. Occurs only once. Yep. Yep. Yeah. No worries. Yep. How creative? So I want you to invent some numbers. Be creative. I mean, okay, so the answer to this is I want to get you to try to think like a mathematician. And I'm more than aware that it's going to be hard for you guys to actually invent some interesting new number. Like mathematicians have been thinking about this for literally thousands of years. Um, but so the new number you invent might not actually be that useful, and that's fine. But just try to invent something. Try to be creative. It's all right if you describe a new number and if it doesn't work. Like most of the times when you try to invent new numbers, things don't work out. Like that's how it is, even for a professional mathematician. But yeah, so for example, you could invent something like colorful numbers. If you think about it, sort of like negative signs are sort of like a color, right? Maybe you can have more of them. So you can think of like positive and negative as colors, but then what happens? Like, why might you need that kind of number? And then what would you need to do to make sure those new colorful numbers fit in with all the existing numbers? So like when we invented negative numbers, we had to make sure they fit in with the positive numbers, right? And so like those are the sorts of things you need to think about. Those are the kinds of issues. So like if you're going to invent something, you need to figure out how it fits in with what you already have. Yep. Okay. Any other questions? Oh, absolutely, absolutely. Let's see. Let's make up some smaller numbers. So like having these really big numbers can be confusing, right? So let's make up a couple of smaller numbers and like try to figure it out, and then we'll try to think about getting bigger and bigger numbers. Okay? So let's start with something super easy. Let's start with 6 and 9. Okay? So what is the greatest common divisor of 6 and 9? Well, just staring at this, you can probably tell that the greatest common divisor is equal to 3. But let's solve this using the Euclidean algorithm. Okay? So what we'll do is we'll start with 9. 9 divided by 6 is equal to, well, what is that equal to? It's 1 remainder 3. So you can use long division to figure this out. We're not going to use long division for this one problem. But then that also means that 9 is equal to 6 times 1 plus 3, right? Does that make sense? So, oh yeah, okay, yeah, sorry. So 9 is equal to 6 times 1 plus 3, and that is exactly the same as what we were doing over here, where we had 1,938 is equal to 75 times 25 plus 65, plus 63. So same step, just different numbers. So now what we need to do is that means that, let's call this D. That means that D is also equal to the greatest common divisor of 6 and 3, right? So then we do the same thing. 6 divided by 3 is equal to 2 with a remainder of 0. So then, because the remainder is 0, that means that we're finished. Okay? And so when you're finished, then that means that the greatest common divisor, D, is equal to 3. Okay, so that's easy enough. This was a very simple, like, one-step solution, basically. So now, what you want to ask is, how do you figure out, write 3 as 9 times x plus 6 times y? Well, what we're going to do is we're going to make use of this formula. So we're going to go backwards in our steps. So when we take this formula, we can rewrite this as 3 is equal to 9 minus 6, and then we're done. Okay? So that was a super simple example with very little of the sort of substitutions that were confusing, right? Because that's just immediate. So now let's make it a little bit harder. So let's consider, what about, let's say we have 15 and 21. Or no, let's say we have, sorry, let me think of a good number. Let's do 11 and 21. Okay? So let's do 11 and 21. Let me see if this is slightly better. So we want to find D is equal to the greatest common divisor of 11 and 21. So staring at this, you might notice that 11 is prime, which means that it doesn't have common divisors with anything else unless they're multiples of 11. So you know that the answer to this is 1. But let's actually try to solve it. So 21 divided by 11 is equal to 1 remainder 10, right? So that means that 21 is equal to 11 times 1 plus 10. And D is equal to the greatest, now D is equal to the greatest common divisor of 11 and 10. Right? So well, let's do it again. So what's 11 divided by 10 is equal to 1 remainder 1. So that means 11 is equal to 10 times 1 plus 1. So now D is equal to the greatest common divisor of 10 and 1. And what's 10? 10 divided by 1 is equal to 10, remainder 0. And so now we're done. And so then D is equal to 1. Really, whenever you get to something, the greatest common divisor of anything in 1, you know that the greatest common divisor is just 1, since 1 has no other divisors, right? Okay, so now we know that 1. So now what we want to do is we want to write 1 as a product, as a combination of 11 and 21. Now this is a little bit harder, right? Because, well, we might start with this one up here. So you notice that this is the first non-trivial equation we have left, right? And we can rewrite this as 1 is equal to 11 minus 10 times 1. Or that's just equal to 11 minus 10, right? So that's our starting point. So our starting point is 1 is equal to 11 minus 10. But now what do we do from that starting point? Well, 10 isn't one of our building blocks. It wasn't one of our combination addition building blocks. So we were talking a lot about multiplicative building blocks. Here we're trying to build it out of these two specific numbers by addition. So what else do we do? Well, notice that we have this next line here that's one above, which says that 21 is equal to 11 times 1 plus 10, which means that 10 is equal to 21 minus 11. Right? So if 10 is equal to 21 minus 11, that means we can substitute that in. So then that means that 1 is equal to 11 minus 21 minus 11. And if we continue that and distribute, that's 1 is equal to 11 minus 21 plus 11. So 1 is equal to 11 times 2, since we have two copies of that, minus 21. And lat here is our solution. So this is 21 times 1. Does that make a little bit more sense? Okay, so let's say that was okay, yeah. So let's do. Okay, so let's do this as, let's say we originally had 43. Okay? So if you originally had 43, then you get 43 times divided by that, and so that would be 43. So I chose 43 because that gives you exactly 11 times 3, which was your question, right? And everything else remained the same, right? So I hope I can convince you that the entire rest of the process is the same for the greatest common divisor. Are you alright with that? So, then we still know that the greatest common divisor is 1, because that's how we constructed it. And then we start with this equation again. So 1 is equal to 11 minus 10, right? But then we want to use the next equation, and that's a little bit harder, because the next equation is 43 is equal to 11 times 3 plus 10. 43 is equal to 11 times 3 plus 10, and that means that 10 is equal to 43 minus 11 times 3, right? So now we substitute that in instead. And so then 1 is equal to 11 minus 43 minus 11 times 3, right? Because what we're doing is we're substituting that in for 10. And then 1 is equal to 11 minus 43 plus 11 times 3. Then 1 is equal to 11 times 1 plus 3 minus 43. So then 1 is equal to 11 times 4 minus 43. Does that answer your question? Okay. Yeah, and so like each time you're just substituting in from the line above it. And yes, it gets really tricky, and you have to be really careful when you're doing something as complicated as this one, because you have a lot of steps here, right? And so you just need to make sure you keep track of everything. But one of the things you can do is, if you're keeping track of everything and you have a calculator, is you can make sure you don't make a mistake on an intermediate line by just plugging that in. So every one of these lines has to be true. So if you plug the right-hand side of that into the calculator and you don't get 3, that means you made a mistake somewhere. Okay, yep. Let's see, any other questions? Yep, try it out. Ask in tutorial. Like, I think I mentioned to your TAs that the Euclidean algorithm is probably going to be the hardest part of like what people are getting confused by. So ask in tutorial, your TA will go through it again, and they'll explain it slightly differently. So like, everyone you ask is going to explain it slightly differently, and hopefully one of the explanations clicks for you. Okay, and I am going to call it a day now, Len. So I'm going to stop recording, and I will see you all on Monday.